Hello guys, today I'm going to tell you about circuit boards or printed circuit boards known as PCBs. The PCBs are the board that you can just solder your component on this board and your system is much in order and is much more effective because designing a circuit board is really important for your system. You can just solder your component in the air or in some I even saw some people even solder their component on a piece of wood or things like that, but it's not okay and you have to start learning how to design and make your own PCB. You don't need to give it away to some company made you the PCB. You can do it in your home. I'm going to explain all the details and all the way. As you can see, this is a circuit board. You can design it with a variety of softwares. I'm going to tell you which software is much easier and you can use it to design your own PCB. Okay, I'm using this software. It's Deep Trace. It's very easy. It's very good, and you can find everything inside this software. Of course, there is other software like Eagle or Altium Designer, but this one is really easy and you can save your files in those format too. Yes, you can change it to Eagle or Altium Designer. So let's go and design a PCB. I'm going to design my last system from the last video, this one on a PCB. So let's see how it works. In here you can find the pattern or the components. Pattern means the package of each component. For example, BGA, you can find all kind of BGA, or you can just simply in a find component you can add, for example, you can select all libraries. From pattern I go to component and I just search 80 mega, it's 80 mega 60, and you click on apply filter. It's okay, it always does that. Okay, as you can see, the software found you about 97 matched components. You can see this in here, but what we need right now, it's very important in the software that you choose the right package. For example, you can see there is a variety of package in a market. It's the dip, this one is TQFP, it's MLF package. It's important what kind of component you bought or you're going to buy, so choose the right package in your software. For example, this one, and some component have several packages, just like this one. It has 2, it has 3, and this one is just one package, or it's a tiny, it's PDIP 8 pin. You can find all of that in this software. I'm going to use deep one, 80 mega deep one. It's the deep one. You can say cancel and it goes back. For example, if I'm going to choose a QFP, it's the BQFP. You can find the dips right here. It's 4 or 8, and just play with this package and you can find all the components in here. So you need a little knowledge about components. You can just search it, the data sheet of those components, and it's okay. It's good to go, and you can find the right component and then you can search it here. And of course you can make your own library. For example, I made my own library. These are the components I usually use, so I added here so I can just I could access this really easily. Okay, in this part I'm going to show you how to design a library. It's very easy, and then I come back and start designing my own PCB. You can go to library tabs and just click on open library. Okay, this page will going to open and you can just design your own library. In here you can add a new library, save it somewhere safe so you can just add it to your software. Even if you deleted your software, the library will remain, so you can just add it to your software. In here you can give it a name and just click on OK and it's good. So in here you can just right click on here and just say add new pattern. There is an untitled, you can just give it a name. For example, I'm going to name it LCD. This is the value, you can give it or not, it's not important. And in here it's the center of your component, so you can just add whatever you want. For example, there is a 16 pin LCD. I'm going to center it here. For example, it's not accurate, but I'm just showing you things. Okay, this one is my whole LCD. You should measure the dimension of your component and just use it here so you can make your own component. So when you do that, when you're done, you can just hit save and you can go out of here, and in here in your library, in your own library, as you can add library, you can add those library to your software. For example, this is mine. I just save that here. it's here, as you can see. Don't mind the name, and you can add it here. So now, as you can see, there is my component I just designed. Okay, okay, we're back and we go to design our own PCB based on our last circuit here. Okay, this one is my 80 mega 16. I can just change the name to 80 mega 16. Okay, I need an LCD. Which one is my LCD? This one. It's the right design. Okay, you can rotate it by R key on your keyboard. Okay, this one, when you hit T or B on the keyboard, you can change the view between top, bottom, and top side and bottom side of your PCB. It's very important that you give the right dimension to your pins. Just right click on each component, hit on path properties, and in here you can choose it's gonna be rectangle or oval. It's up to you. I'm going to change some dimension, and I hit on apply to all paths, and it's here. They're close to each other, so I changed it to 1. This one should be 2.5. Okay, it's thicker. It's better when you want to solder your component to your PCB. They have a better strength, so they won't come off by heat, or you don't destroy your PCB. So always remember about your trace and your pins. Okay, I just going to add some component. For example, I need some resistor. In here I have a resistor. I designed it before. I need 2 key. This is small keys. Yes. You can just copy and paste your component in a screen too. And I need a potentiometer. This is hot. Okay, and 2 LEDs. Where is the LED? Okay, it's on. Okay, and we can just go and okay, my LCD is connected to port A. Which one is port A? In here, when you move your arrow on a pin, right here you can see the name of the pin. It's 80 mega 16 pin 40. It's pin A, that's 0. Okay, there's some tools in here and you can use it. I'm going to explain it one by one. This one, it's called rat lines. Rat lines means the lines between each pin. It means which pins are connected together. It's best that you use this tool and show which pins are connected together. Okay, pin 1 is our ground. Of course, I need a power supply too. Of course, you can move your component just by selecting them and push the arrow key on your keyboard. The precision of movement, you can adjust them from here by millimeter or inch. It's up to you which one you want to use. You can change your units in view and units. It's on millimeter and inches. Of course, if you want to delete a rat line, you can just go through your pin again. When you do that, it asks you, do you want to delete this rat line? You can say yes, and it's going to be deleted. Okay. Okay. Now all my rat line are connected. Of course, remember in the simulation, there is no VCC or GND pin on microcontroller or most of ICs. But in a real PCB, you have to remember this one. This is pin 10. It's VCC. It goes to positive, and the GND goes to GND or negative. And you should know this system is operate with 5-volt DC. All the rat line are connected, and now we have to just make our system in order and more prettier. So I just change the position of some component. Of course, there is an option placement, and you can say you can just hit auto place. Uh, it's going to place your component in order. For example, this one. But for me, I like to do this on my own, and I think it's work better. These two components are not at the same surface, so this microcontroller goes under the LCD, so uh, it's okay and we don't have any problem. Okay, this is, for example, it's our clock. This one is our power supply. This is the LCD. All components go under the LCDs, so our clock could be really minimal, and I think it's better. These two LED should not go under the LCD because we need to see them. And there's two key for adjusting. Now I'm going to connect the real trace here. This blue line are rat line. Um, they're just for a guide, for your guide, so you can know which pin connected to which one. But the real trace comes from here. You can just, for example, add some trace between each pin, and of course in this trace no uh, traces should cross each other because it means they connected to each other. It's not like rat line. And remember, uh, you wanna make a single layer PCB or a double layer. In most cases we need just a single layer, so we should go to a root and layer setup, and in the top we should hit click on the plane, so there is no trace on the plane or the top of our PCB. And of course we have an auto root too. In auto root, in here, if you click on auto root, it's going to uh, put all your trace in the best way the system can. For example, I'm auto rooting now. Okay, this one is the top view. You can change it by this, or just hit the B on your keyboard, top T and B. Okay, you can see it's your PCB is okay, and all root are changed to your rat lines are became the real root, and your system is okay. But again, I prefer to do this by my own and by hand, so I'm going to do that with a fast motion, so you can see what I'm doing. With this tool you can measure the dimension of your board. Okay, I'm going to top view. It's about 10 centimeter, and here it's about 4.5 centimeter. You can see the size of your board. And there is some other thing, it's optional, but I like to always add this to my PCB. It's been called copper pure, so I'm just hit on this. It asks you which kind of characteristic do you want. For example, we say solid. The clearance is let me tell you, it became like this. It's going to be fill the empty part of your board. It's much better because when you are trying to make this PCB, it will consume the less etchant you need to make this PCB. So I recommend you to do that. And of course you can change the appearance of this, but this one is much better. And of course the clearance is the distance from our mask to the trace. For example, if I change it to 1, you can see, and of course you should hit the update. It's really close. It might be not best when you want to make this PCB in home, so I recommend use 3 and above. Okay, your PCB is ready. We're going to save it, and now we're going to make our PCB. Okay, the design is complete and we are going to print our PCB. Okay, now I'm going to print this circuit because this is one of my projects. I want to make a PCB out of it. So and I just want to print the bottom side of my PCB. Okay, I'm moving to the side of the page. Print in black only, and in objects. In here you can adjust which part of your circuit is going to be printed. For example, I don't want dimension and I don't want silk, and for example, let's see, you can add or remove all parts, for example pads. Okay, this is all I want, and of course some rat line. I don't want this rat line to be shown on the circuit board because they're not supposed to be printed. And just I'm going to hit the print. Okay, and remember you have to use a LaserJet printer. Of course it depends on your quality of your printer and its tuner. Your circuit board quality depends on these two factors. Okay, my paper is A4 and the resolution. Okay, I just hit the print and see what's happened. Okay, I just printed my circuit on a piece of paper. Of course, you can print your circuit in any kind of paper. Your paper must be glossy enough so you can transfer your circuit to the PCB board, and it shouldn't be too much glossy because your printer cannot print on this kind of paper. So I just on my own experience I just know some kind of paper. It's actually a sticker paper. As you can see, you can just, it's the sticker one, and I am going to print on this side, the glossy side. Of course, it's not working in all kind of paper. You have to just buy and test on several kind of paper so you can find the suitable. Okay, I just printed. I'm going to cut it. Of course, the quality of your printer is really important for the quality of your PCB. And about your PCB, you have to just sandpaper your PCB so it will become shiny. Don't do this in this one is so oxidate and it's not good. You're gonna face some problem along the way, so just use a shiny one. Okay, now all you need is an iron, or maybe some device you can heat your paper, and you could pressure on the paper so it sticks to the PCB. I'm just using some old iron, as you can see. So I know this is the Stone Age iron, but it works really great actually. I recommend you that you put a piece of paper on your circuit when you're trying to heat it. Don't move your iron like this, just put it on a PCB and just press it. Your iron temperature should not be too high or too low. You're going to understand it in a few times when you try to make a PCB, and just choose the right temperature by your own experience. Okay, I'm going to press it for the last time. And remember, in that time, you have to just put your board in a cold water very fast. Okay, now I'm going to put my board into the water. The paper is on the upside. You have to push it and just let it. As you can see, the paper is getting wet. Of course, there is some part of your print is still on the paper. Of course, you can't do anything about them. You have to repair your board with a marker. To be honest, if you want a perfect PCB, you have to use a new and original tuner on your printer. It's really important because the lines are thicker and they're much filler, so you won't be having any kind of problem like this if you use a good tuner on your printer. Okay, now I'm going to fix this board with a waterproof marker. You can find different kind of marker. Just use a blue or black. It doesn't matter what color do you use, as long as it's waterproof. Okay, the board is ready. I fixed all the problem all on the PCB, and now it's time to put this on the acid, or actually it's some kind of etchant. Okay, this etchant is called ferric chloride, uh, and it's of course it's poisonous if you drink it, or a kid would drink it, but to your skin it's not really harmful. It's not like acid, but it's best not to contact your hand, because your hand gets really dried, and it's not good for your skin. Of course, what you can of course you can find this in a liquid form and solid powder. What you should do, just put a little of this etchant into a plate or anything, and add some hot water on this etchant. Of course, the gas, there's gonna be a gas produced by the hot water. Try not to breathe on that gas. It's not poisonous, of course, but it's not good either. And of course, some people might believe they should put a lot of this liquid, so the board will become ready faster, but it's not. The less concentration of this liquid with water it works better than the high concentration. It's a fact, and it works on acid or any base too. Okay, I'm going to put some hot water in it and see how does it work. Of course, if the liquid is warm, it will dissolve your copper, and the board will be ready much faster. The copper on the edge of here, as you can see, the copper on the edge of the board is completely dissolved. Okay, now as you can see, the board is ready. I'm going to wash it and show you how it now the board is ready. Now you can just sandpaper it, and but I use this kind of washing wires, and I think it doesn't inflict any damage to the board. Okay, now this is our board, and it's not perfect, but it will do. It's really good. And just remember, when you're trying to put your board on
the etchant, you should be careful. Don't let your board be in that liquid for too long, because it doesn't matter. There's those black cover on the board, and this black cover it will destroy your board anyway if you put it on the water for on the liquid for too long. For the last part, we just need to drill all the holes on the board, and for drilling them you just need to make one of these. It's much easier to use than a big drill bit. You can see there's different kind of drill chunk. You can find it in internet. You can simply buy it. It's really cheap, and you can just buy a DC electromotor and use it with your power supply, or just an adapter, and it doesn't matter how volt it is. It just have to has enough speed and power to do your job. And of course you just need to buy some drill bit. Most of the drill bit you need in making a PCB, it's from 0.5 to maybe 1 or 2. So the drill bit, I have several number of this drill bits, as you can see here. And of course you can find this kind of drill bit in the market. You can see them. They are so perfect, very good, and they are amazing. But the problem is they usually used by CNC machine, and by hand. If you move your hand slightly a little, it will break, and it's a little hard to use, but they are perfect. If you try to buy them, it's really perfect. Now I'm going to put my power supply 16 volt, because my motor works in 16. You can see it's moving, and it's really easy to use. You can see the holes here. So this is how we make a PCB. Okay, from now on I recommend you to make a PCB from all your projects we are working together. When you make the PCB, you just have to put it on a box, and you have a completely perfect system, and it will work for you for days and years. And of course, after you solder your component, I recommend you to just use a nail polish. You can use a colorful one, or maybe just transparent, and just brush the back of your PCB so it doesn't get oxidized by the oxygen from the air. So everything is fine, and Good luck.